Hello everybody, this is Shankar from SystemBaseLabs and welcome to From Models to Autonomous Enterprise Systems. And today we begin Module 2, the foundations of machine learning systems. Now honestly, this module represents one of the most important turning points in the entire history of artificial intelligence because for the first time machines would no longer depend entirely on handwritten rules. They would begin learning directly from data. Now think about how revolutionary that idea really was. For decades, AI systems depended on human experts manually encoding intelligence. Humans wrote the rules, humans defined the logic, humans maintained the workflows, and machines simply executed predefined instructions. But eventually, the world became too dynamic for that approach. Enterprise systems became massively complex. Customer behavior evolved continuously. Fraud patterns adapted rapidly. Markets changed unpredictably. Language evolved constantly. And static intelligence systems could not keep up. Now, this forced researchers to ask one of the most important questions in modern computing. Instead of programming every rule manually, what if machines could discover patterns automatically? Now, that question changed artificial intelligence forever, because this became the birth of machine learning. Now let us simplify machine learning at a very practical level. Machine learning is the ability of systems to learn patterns from data and improve predictions over time without being explicitly programmed for every condition. Very important distinction. Traditional systems followed instructions. Machine learning systems learned relationships. Now this introduced an entirely new architectural model. Earlier AI architectures looked like this: rules, logic, decision. But machine learning changed the architecture into data learning prediction. And this transition fundamentally transformed enterprise intelligence systems. Now, instead of manually encoding every possible fraud condition, recommendation pattern, or customer behavior, machine learning systems could statistically learn from historical data. Now let me give you a practical enterprise example. Suppose a bank wants to detect fraudulent transactions. In deterministic systems, engineers manually create fraud rules. If amount exceeds threshold, flag fraud. If location changes suddenly, flag fraud. If login pattern changes, flag fraud. But in machine learning systems, the model analyzes millions of historical transactions and automatically learns behavioral patterns associated with fraud. This was revolutionary because systems could now adapt to evolving behavior. Now, from an enterprise perspective, this changed everything. Machine learning dramatically improved fraud detection, recommendation systems, risk analysis, forecasting, customer intelligence, behavioral analytics, search systems, and predictive operations. Suddenly, AI systems became more scalable, more adaptive, and far more data-driven. Now another major shift also happened during this era. Data exploded globally. The internet expanded. Cloud computing accelerated. Mobile systems generated enormous behavioral information. Digital platforms created continuous data streams. And organizations suddenly possessed something incredibly valuable: massive data sets. Now data became the fuel of modern AI. And this gave rise to what we now call statistical intelligence. Now, this is extremely important architecturally. Earlier, AI attempted to simulate intelligence through logic. Machine learning approached intelligence through probability and statistical relationships. Very different way of thinking. Machines no longer needed to fully understand something logically. They only needed to identify patterns accurately enough to make predictions. And honestly, this changed enterprise architecture forever. Organizations shifted from workflow-driven intelligence to prediction-driven intelligence. Now, recommendation engines predicted user preferences. Banks predicted risk. Retail systems predicted purchasing behavior. Industrial systems predicted equipment failure. Healthcare systems predicted disease patterns. Prediction became one of the most valuable operational capabilities in enterprise computing. But machine learning also introduced new challenges: bias, training complexity, data quality issues, model drift, explainability limitations, operational governance concerns. And eventually, machine learning itself evolved into something much more powerful, deep learning, then foundation models, then generative AI, and now agentic AI systems. But all of those systems emerged from this single revolutionary transition, machines learning directly from data. Now, before we close, I want you to remember one important architectural insight. Machine learning did not replace intelligence with logic. It replaced static rules with adaptive prediction systems. And that shift became the foundation of modern artificial intelligence. Because once systems could learn from data, the future of AI changed permanently. And in our next session, we continue Module 2, the foundations of machine learning systems. Video 2 of 6, Class 8, Supervised Learning and Predictive Intelligence. How machines learn prediction through labeled data. In Class 8, we will explore how supervised learning systems actually work, how machines learn using labeled data sets, how prediction models are trained, why classification and regression transformed enterprise computing, and how predictive intelligence became one of the most valuable operational capabilities in modern AI systems. We will also explore training data, features, labels, prediction pipelines, model accuracy, enterprise forecasting systems, and operational prediction architectures. Thank you, everybody. This is Shankar from SystemBaseLabs, and I will see you in Class 8, Architecting Intelligence. Good luck and goodbye.